Hi folks, we're going to look at an example of sketching a function as a transformation of a parent function. So say you're asked to graph this function here. So keep in mind what we're trying to avoid doing is just inputting x values into the equation and finding points, because there's no guarantee that the points we find on our table of values will really give us a sense of the shape of this graph. So what we want to do is we want to graph this compared to a simpler function. Okay, so first thing we have to do is to identify what parent function we're comparing it to. So we look here and I see that I've got my variable x, and at some point, if I were to do some algebra on this expression, that x will be squared. Okay, so what we're going to be doing is comparing this to the parent function x squared. Okay, next thing is to identify what transformations we have on this function here. Okay, so if I look, normally my input to x squared is x, but I see that my input is x minus 3. That's the expression that's being squared. So identify that as a horizontal translation. And remember, horizontal translations, the effect is always the opposite. So here, when I have a minus 3, the effect on the x components is actually to add 3. So it's going to be a shift to the right of 3 units. I see here that I've got, after taking the square, okay, I have a plus 2. Okay, so it means to the outputs, after I take the square, I'm going to be adding 2. So we recognize that as being a vertical translation up by 2 units. And I see here, after the square has been taken, I'm multiplying by negative 2. That in fact holds 2 transformations. The negative means that there's a reflection in the x-axis, and the 2 means that we have a vertical stretch or a vertical expansion by a factor of 2. So we're going to be multiplying all the y values by 2. Now, you might actually prefer rewriting this explicit formula for a function in terms of function notation. Nothing stops you from doing that. So again, here, if f represents our parent function, then our input now, instead of being x, becomes x minus 3. We're multiplying that output by negative 2, and then to all that we're adding 2. Okay, so you might find it easier to identify the transformations if you take this explicit form and turn it into function notation form. Okay, so you do need to be able to work with either of these. Now let's actually go about determining the points on my new function here. So again, I'm going to repeat, we're not sticking x values into this equation and evaluating. Okay, we're comparing everything to our parent function x squared. So the first thing we start with is points on our parent function. Our 3 representative points for x squared are 0, 0, 1, 1, and negative 1, 1. So our goal now is to determine how these points are transformed based on the transformations we've identified. Now, we also saw that the order in which we apply these transformations does make a difference. In order to get the correct answer, we need to apply them in the same order as BEDMAS. So we need to apply the multiplicative transformations before we apply the additive ones. Okay, so the first thing I'm going to do is I'm going to figure out those multiplicative transformations. Now the way in which I identify this, since I'm going in stages, is my next step will only take into account the multiplicative transformation. So I'm going to write negative 2 f at x. Okay? So I'm not considering the additive ones yet. Okay, so the effect of multiplying my function by negative 2, okay, I know I'm going to be multiplying the y values, okay, by 2 and by negative 1, but I can do that all in one step. I'm multiplying my y values by negative 2. So the x components will not change, but the y components will all be multiplied by negative 2. So not surprisingly, this doesn't change, but this now becomes negative 2. This becomes negative 2. Okay, and the last step now is to incorporate my additive transformations. But because the horizontal and vertical translations each only affect one of the components, I can perform these in the same step. So now I'm going to incorporate all the transformations. So that's why now I write 2 times f at x minus 3 and then plus 2. Okay, because now I've incorporated all transformations, okay, including the one I've already done. So the last step now is to incorporate the additive ones. So as we said, when I see f at x minus 3, I know I'm going to perform the opposite operations on the x components. I'll be adding 3 to all these x components. So 0 plus 3 is 3, 1 plus 3 is 4, negative 1 plus 3 is 2. Okay, and here we identified this as a vertical transformation 2 units up, so I'm going to be adding 2 to all the y values. Okay, so what we have is we started off with 3 points on our parent function, and we transform them into points which lie on the new function. Okay, now that I have these points, I can sketch the graph. Okay, so here, choose your axes. So I'm going to need, the y values are pretty small, so I think I'm going to have my boxes go up by 1. But I need to get up to 4 for my x component, so I might move my y-axis a little further to the left. Okay, so depending on your points, you choose where you put your axes. Okay, so my y values are all going to be positive. Okay, so I'll put my x-axis a little lower here. Okay, so here x, y. Since the numbers are small, I can increase just by 1 every time. Okay, and now I can go ahead and plot my points. Okay, so the point 0, 0, which was at the tip of the parent function's parabola, now will become 3, 2. So 1, 2, 3, 1, 2. Okay, and then I've got 4, 0, 3, 4, 0, and 2, 0. Okay, so since this is the tip of my parabola, I know it's going to be going downwards. So it'll look something like this. So we don't have a perfect graph, but we have a graph that gives a sense of the shape of the function. Okay, so let's recap. Okay, first thing is to identify the parent function that we're going to be comparing to. In this case here was x squared. Next thing was to identify all the transformations based on those operations. Next, we transformed specific points on our parent function, and we did it in the correct order. So first the multiplicative transformations, and then the additive transformations. And then from there, I can sketch the graph of my function. Okay, so work on some of these. Okay, and again, what I want to see is I want to see both the effect on certain points and then the final graph. Okay, that's it for now.